are Nicolas Pierre and Luc Dini, both members of 3AF, which is the Association of Aeronautics and Astronautics in France. They're particularly part of the SIGMA2 group. The name of the lecture is a SIGMA2 Commission, a collaborative and multidisciplinary approach to investigating unidentified aerial phenomenon. Nicolas Pierre, his domains of expertise are high energy density physics, magnetohydrodynamics, pulse power technologies, and inertial confinement fusion. Luc Dini is the chairman of the 3AF Technical Commission SIGMA2 on UAP studies. He's a fellow member of the Association of Astronomics and Astronautics in France, 3AF. He's a graduated engineer in aeronautics, skilled in missile, space, high atmosphere radiation, IR and visible phenomenology, air defense, IR and radar detection, and hyperfrequency. So thank you, gentlemen, for joining us, and we'd love for you to begin your presentation.
Thank you very much, Alejandro, for this very kind introduction. It's really my pleasure to take part to this UAP webinar organized by SU. I would like to thank warmly Robert Powell for the different talks we have had for years, and also Rich for the very professional preparation of this webinar. This talk will deal with the EEF and SIGMA2 activities related to the study of UAPs. Our activities, but also collaborative activities together with other organizations, including sharing analysis with SCU, as we did in the past, and I will come back to that later. Nicolas Pierre will participate, in fact, indirectly. He supported the preparation of this presentation, but I will be the speaker now. So, to be very clear on our presentation, we'll go through a very short introduction to the EEF SIGMA2 Technical Commission, then go through some agreement that we have already with societies or institutes on the UAP studies, and then make a tour, a fast tour around the anomalous observables. What are they? And give some illustration of UAP cases studies based on what? Based on optical signature analysis specifics, but also on ground traces and then on radar observation. And I will terminate this presentation by a summary about collecting data on anomalous phenomena, which kind of sensor, what can be done. First of all, what is EEF? EEF is a scientific society, okay, very similar to the ARAA, smaller, of course, based on 1,500 members, but also on collective members, including the CNES, which is the French Space Agency, DGSE, equivalent of FAA, Ministry of Defense, and also engineer schools, aeronautics and astronautics industry groups. Among that, the mission of this EEF society is based on two things. One is organizing international conference on different subjects, can be green aviation, can be space propulsion and so on, but also technical commissions, which are made of experts. And we have about 20 technical commissions dealing with commercial aviation, light air machines, drones, flight tests, space observation, and so on. And there is a technical commission which is very special, which is named SIGMA2. SIGMA2 is a commission dealing of UAP studies. It has been created in past, in 2008. The first name was PAN for UAP, and then it was renamed SIGMA and SIGMA2 in 2013 when I took the lead of this commission. I will come back to the details about the SIGMA2 commission. So, what are we doing, in fact? Our work is based not on ufology, okay, but on expertise in different technical domains related to astronautics and aeronautics. And we defined the mandate of this technical commission, starting by research on documentation. The objective of that was to look at what are the organizations already existing, where are the database, in order to get data and to conduct our own analysis on the UAP cases. Of course, in order to make contact, we needed to communicate and to elaborate some contacts and agreements. And I will come back to that, but we have agreements, for example, with SCU, and we started cooperation many years ago. Based on this rationale, we came to selection of cases, UAP cases, okay? Based on database, including, of course, for France, the GEPAN database. You will see a slide about that. And then we come to the physical element study. So we have experts coming from different domains. For example, we have pilots. We have conducted studies with a former Air Force pilot, Brigadier General, an expert in air defense, for example, for the Aquadia case or the Cougar case provided by the Chilean CEFA. We have engineers, we have people conducting research like Pierre on the plasma, experts in electronics, infrared detection, radar detection, ball lightning, and so forth. So this melting pot of experts, between 20 and 25 of them, are really supporting the analysis that we are conducting and that I'm going to illustrate. On this slide, you will find some reference with documentation that we published in English, and one of them is a record of a webinar, a scientific webinar that was held very recently. It was in June, with participation of SCU, of SUPS, and also from other contributors like Massimo Teodorani, but also Dr. Villarroel and many others. We had a very successful webinar on UAP optical observables. We have also provided some report, one analysis on the ODNI preliminary assessment on UAP that was published in 2021. And we also published two reports, one which is a summary, which is completely available directly on the website of EEF on the analysis from SIGMA2 on UAP, and a complete one, which is also available. It's a bigger one, about 400 pages, okay, looking at different cases and history of the cases. So I invite you, if you are interested, to look at these links and upload documentation, and we will be very pleased to answer any question. Now, what about the UAP, and is there a way to make difference with atmospheric phenomena? That's a big question. If we are looking at optical observable, if we come back to different phenomena like Esdalen phenomena, okay, events, some luminous spheres traveling very fast. There was a very interesting presentation about these events that was made at CAIPAN2, which was a seminar organized by the GEPAN, which is an organization depending of the CNES, the French Space Agency, working specifically on UAP. Of course, we had the four fighter during the Second World War. So we are facing some luminous phenomena. And sometimes we don't know exactly if they are from artificial origin or if they are natural origin. That's something that we are going to discuss now. Before that, I would like to emphasize that the study of UAP is not a recent story in France. In fact, it started in the 50s. Okay, you have on this screen a document which is in French, but this document was a document made by the Ministry of Defense in 1954. This document was transmitted to the different forces, okay, Navy, Air Force, Gendarmerie, and so on, in order to conduct investigation on what they called not UAP, not PAN, which is the translation of UAP, if you wish, in French. At that time, the name was Mystérieux Objets Célestes, celestial, mysterious objects, MOC. So you see, this is not a very recent story for us. And we had different reports. This one is a copy published by CNES GEPAN, showing a report from the French airbase in Cognac. It was in 1956 or 7, I don't remember exactly, and it was a report sent to Paris, to the Ministry of Defense, reporting UAP observation. Now, coming to today and the CNES, CNES is conducting investigation on UAP, and the GEPAN was created in 1977. And it's conducting analysis, investigation on UAP cases reported by French citizens. Okay, so they have their classification, and in our case, the SIGMA2 commission is really looking at what we call the D cases. The D cases means what? It means that there are reliable cases in terms of type of data, in terms of reliability of testimonies and so on. However, these cases are not explained, okay? We couldn't find, or the GEPAN couldn't find, I could say, current explanation of physics, meteorology, or whatever, to explain them. So they are unexplained cases, and we are focusing on that. Of course, we can do the same for foreign cases. And as I explained, we have already worked and had cooperation, for example, with Chile, with the CEFA, which is equivalent to the CNES GEPAN, and they provided a very famous case, which was the Cougar case, and I will come to this case later. So our analysis is focused on what? On physical analysis, physical elements. So we need data, okay? A testimony, a sighting is very interesting if we have technical data, if we have recording, if we have radar data, infrared data, both are very important, and I will explain why. And by doing so, we are developing an observability approach, and we can provide some recommendation, for example, to improve the sensors network so that we can collect more data, and we could also exchange data with other organizations. That's our final recommendation. And we are issuing reports. For example, we issued reports on the Aquatica case. We crossed analysis with SCU. We issued a report on the Cougar case, where we clarified what was, in fact, the object that was observed. And in the report, which is available on the AAAF SIGMA2 website, we have different types of analysis, different type of analysis of plasma effects, that sort of phenomena, part of our report, and you will see this is very, very detailed, very interesting. Now, what about the organization with which we have some agreements? Of course, we are working with the CNES GEPAN. Some of our experts are part of what we call the expert college of GEPAN. GEPAN has a college of investigators, okay? They are doing the field work in terms of investigation, analysis of what happened. And then you have the experts who are going to analyze the data. This is the College of Experts. We have an agreement with Chilean CEFA. We had also an agreement with the US NARCAP. We are working with the laboratory of research on ball lightning in France, and his director is part of the SIGMA2 commission. We are working with the Observatoire de Paris on observation with the institute in charge of comet and meteorite observation. We have a recent agreement with SCU, but as I said, we have started working back, I think, to 2017. Very fruitful work, and we are continuing together, and we are preparing other kind of agreements with SUAPS and AIAA probably too. Now, coming to the optical observation. First of all, we are facing a very strange observation of phenomena, providing, for example, different kind of shapes, change of shapes, and so on. You see on these pictures, pictures of stealth bomber, okay, UAVs, missiles, hypersonic missiles, triangular shape, and so on. The point is that in the middle, okay, you have different types of shapes matching with observation reported about UAPs. And the point is that we have, for some specific observation, people reported not a single shape, but a change of shape, okay? And that's what we are seeing on the next slide. This slide is showing what? This is showing some pictures. Some are well known, okay, they were collected and proposed in different TV shows in the US, but here, the second line is showing real pictures of UAP taken in France for the two first, okay? These are elliptical shape, okay? These photos were made in 1975 in the north of France by military police, okay? That's very strange because we had two objects, okay? Orange, and they were static, and then they moved slowly, you know, with a change of trajectory, you know, some kind of winding trajectory, if you wish, and then they accelerated. Okay, in the middle here you have a shape, which is an elliptical shape. It was a drawing from Captain Boyer. This is a very interesting UAP case that was part of Leslie Kean book that I read in 2014, and we discovered the Jersey case, and we are working very hard on this case. We collected radar data, and the analysis is not terminated, but that's very interesting. And just in the middle of this picture, we see a very famous case in France, which is called the Duboc case. It happened in 1994. It was an observation that was made by an Air France crew on Airbus 300. It was a flight from Nice to London. And the interesting part that I will detail later shows a circular shape, okay? Then changing of shape like a dart, okay, with a very blurry side. And then this dart, you know, was clear and accelerated and disappeared. That's very interesting, and especially because we had not only visual observation, but also radar track recording from the French Air Force provided to the CNES, and we will come back to that more in detail. So we are focusing also on the optical observables, and there is a question mark about how we observing objects surrounded by plasma, for example. We saw a lot of articles about that, and what is our opinion on this plasma effect? In fact, it's very depending on the kind of UAP observation. We can have, for example, an optical light glow effect, single spot, or multiple spots like a group of lights. They can be blue, they can be white, they can have, show a color change. And we have interesting cases described, for example, the very famous RB47 observation. in the 50s, where we had also electromagnetic wave recording about 3 gigahertz. That's something interesting because this type of frequency can be linked to plasma generation. We will say some more words about that. As I said, we can have change of shape. We can have a hovering object, but it can also show a very strong acceleration with low inertia appearance. We can have microwave pulse effects. That's true on electronics equipment, and we had discussion with SEU about that. There is a case that we can analyze together. We have the Tehran case, which is very famous, where two F4 were confronted to a UAP. They engaged hunting, and then their electronic device on board, including the fire control system for missiles, were neutralized. Okay, that's something which is very interesting as well. And we have also effects on environment, on vegetation, on human being, and we have observation of light balls that can be similar to ball lightning, but also in some case to a nuclear striation. Okay, so that's a very complex subject, and we need to go further to see if in some case we have plasma generation, and if it's the case, why? Then I would like to spend a few minutes to give some explanation about what is an optical signature, because sometimes there is some confusion. In fact, on the left part of the screen, you have the object, okay? An object, for example, transmitting infrared radiation. This infrared radiation will be the combination of the thermal radiation, okay, due to temperature of the object, but also possibly to a spectral signature generated by a gas, hot temperature gas. It can be also the scattering of external light, like, for example, atmospheric light, sunlight on the object. So you see, you can have different factors, different sources of radiation coming from the object. And at the other hand, on the right part of the slide, you have the optical device, the infrared camera, for example, capturing this light, this radiation. In between, something is happening. Along the line of sight, you will observe different interaction with the medium. The medium can be the atmosphere, the air, okay? It can be water if the object is under sea. And this interaction, okay, will show, for example, scattering, interaction between the photons, the radiation coming from the object, with the medium, okay? The photons will bounce, if you wish, on the molecules or the atoms, okay? And there will be a modification of the radiation traveling again through the atmosphere towards the camera. We can have spectral absorption due to the gas present in the atmosphere. We can have the scattering of the light, for example, like the sunlight. Okay, the blue color of the sky is due to the scattering on molecules inside the atmosphere, and then you can have an attenuation of the radiation transmitted by the object. Okay, so scattering of light in the medium, absorption of the radiation transmitted by the object, and possible cell formation, okay, from the object or something around. For example, if you take a missile or a rocket, you will have the thermal transmission from the rocket itself, but also the interaction of the gaseous exhaust from the rocket together with the atmosphere. That can be also the case in case of plasma. A re-entry vehicle, a shuttle will hit the air and create a radiating plasma. So, having said that, I think you have a better understanding of the story, of the history of the radiation between one object and a camera, and this is fundamental to understand what can happen with a UAP. Last explanation here, you have a thermal imaging of a person, okay? On the left hand, you have a pot, and the pot is dark because, in fact, this is cold. And on the other side, okay, you have a spoon. It's merely the same color, okay, the same temperature. The point is that it's not cold at all, okay? It's just very reflective, and it's just reflecting, in fact, the infrared radiation coming from the background, okay, not the object itself. So if you have a very reflective UAP, okay, like it's mentioned by Dr. Kirkpatrick, if I remember, in this case, the reflection of light can be the signature of the object, and not only its thermal signature. Now, coming to natural effects, we have natural phenomena like ball lightning that could be confused with UAP. These are, for example, high altitude ball lightnings, okay, created, for example, by seismic activity. You have not only one, you have 4 light balls traveling very fast. They can reach, for example, sound velocity, okay, Mach 1, but not exceeding it. The point is that if we compare that with UAP, these trajectories are quite regular trajectories, okay? Even if the speed can be high, okay? They are not changing of direction quickly. They don't have very strong acceleration. So this is a discrimination, if you wish, that can be made between natural phenomena like ball lightning and UAPs. Now, of course, you have other kind of activities like sprites, okay, which are very light transient effects happening in high altitude in the ionosphere. It doesn't last a long time. It can be observed by human being, but also by fast camera. You can have some experimentation. For example, it could be that's the case that happened in Petrozavodsk, and it could be explained, by artificial generation of the equivalent of nuclear striation, okay, possibly. In this case, you can have also plasma generation by energy deposition. If you wish, plasma is a gaseous medium which is heated, okay? Heated by what? By energy deposition. This energy deposition can be created by electrical arc. It can be created by, in fact, high speed in atmosphere. It can be created by a strong, very intense electromagnetic field, creating an excitation, for example, of nitrogen. Okay, nitrogen is an important gas part of the atmosphere, and then you can obtain, for example, some kind of blue glow, and this blue glow has been observed in some cases of UAP. Here on this slide, you see examples of plasma radiation due to atmospheric reentry or hypervelocity in atmosphere. That can be the case of hypervelocity missile. It can be the case also with meteorites, which is natural effect, okay? You can have also optical radiation, as I already mentioned, for example, from a rocket, okay? And you have the object by itself, the booster, but you can have also a arc of shock between the gaseous exhaust from the rocket together with the atmosphere, with the atoms of oxygen at very high velocity, and it creates radiation as well. So we have to take care of all these phenomena to make difference with UAP, or to record specifics of UAP signature, giving indication on the temperature, giving indication of possible plasma, gaseous species, and so on, to know better what is happening. On this slide, you see, for example, a case of plasma generation, then you can have electrical discharge that can create, by deposit of electrical energy, plasma by excitation, for example, of nitrogen species. Okay, I would like to comment this photo on the right. It was provided by SCU. It's related to an observation that happened, I think it was in 2017, probably. It was an observation by two hunters in Ontario, and they had their smartphone and also a web camera, and they tried to take photos, but in fact, it didn't work, but they saw an object surrounded by a blue glow. And this blue glow seemed to have some kind of pulsation. Okay, they recorded some kind of pulsation with the camera, and maybe it could be explained by an electromagnetic field, very intense, pulsing and creating an excitation, maybe, of nitrogen species around the object. These are hypotheses. Okay, we don't have enough data to make any conclusion about that, but it could be an explanation. And here you have a drawing of the terrain case where when the F4 fighters tried to intercept UAP, the important thing was in fact the neutralization of the communication and of the fire control system on the aircraft when they closed the UAP. Now, a few examples and explanation about observation analysis of UAP cases. Quickly, we consider that when we have infrared data provided by infrared camera, this is very interesting to get information on the shape of the object, possibly on details, possibly having a thermal scan of the object. However, the point is that you don't have accurate geometrical information, and especially you don't have the range, okay, or the velocity of the object. What you have is angular information and thermal information, which means that this is very important to get additional data and radar data, for example, in order to elaborate 3D information on the kinematics, okay, position, velocity, which is of great help to understand where the object is, okay, what it is, how it's traveling. And then by doing math, you can rebuild what is happening around the object and on the path of the line of sight. If you remember, I explained that you can have the effect of atmosphere, the effect on medium, modifying the signature of the object which is observed, okay? And I'm going to give you some real examples. For example, here, this is the cougar case, okay? So we had very interesting data provided by the Chilean CEFA. I have to thank them very much because they provided very simply and honestly all the data they had, okay? Atmosphere, meteo information, the full infrared camera recording, but also radar recording, okay? And that's very important because when you see this picture, you see, well, 3 hotspots. Here you see maybe 2. Here you see a plume. You don't know what it is, okay? But if you can make cross-check with radar recording, it can ease the task, and that's exactly what happened. In fact, we had information about the cougar trajectory, which is in white on the left. We had the infrared recording, okay, second after second, and we saw different kind of shapes, okay? So question mark, what happened? And first of all, we used information, additional information, which are the radar tracks of different aircraft, okay? These are this red track here, the blue, the green, and so on. And we conducted analysis of this track step by step. And the point is that, in fact, we compared the observation from the helicopter, okay, which is the green path here, together with different aircraft paths, and especially with one, which was close enough, but outside the observation limit that was given by the CFA at the very beginning. In fact, we consider the possible identity of one aircraft, and we rebuilt the image of this aircraft within the camera, okay? We look at what was the shape, the geometry of the aircraft, where were the engines, okay? 4 engines, okay? And we moved, along the path of the aircraft, taking into account, of course, the inclination of the aircraft and so on. And at the end of the day, okay, what we showed is that it was matching with the infrared image. We had, for example, 2 or 3 hotspots, and it was clearly matching with the position of the aircraft, and not only the position, but the inclination. That's when, for example, on this picture, when the aircraft was turning, okay, we saw, in fact, in this case, 4 engines, and in fact, we had 2 plus other 2 hotspots, which are the 3 ones that we saw at the beginning. So just to say, this is important to look at very carefully what is happening on an object. We had some ideas, of course, of what is the thermal signature of an aircraft. We can have, for example, the thermal signature of the engines, okay, the nozzles, which is about 1000 degrees, but also it can be the reflection also of the sunlight on the contrail. And then in this case, it's not cold. The contrail is cold, but it's built of small chunks of ice or droplets of water, which are just behaving like mirrors, small mirrors reflecting the light of sun, which is very hot by now. It's about 6000 degrees. So, end of story on Cougar. We have conclusion. This is, in this case, Air 440 Airbus. Then, of course, we had another case, which was the Aquadia case. We worked together with SCU. The point is that we have an object that was tracked by an aircraft with infrared camera. It's very difficult to have a clear analysis. We see this tumbling a little. It looks like it's changing of attitude. But at the end of the day, we have made several assumptions. First of all, because it's very depending on the trajectory, whether we consider very low altitude profile for this object, like, for example, when it's flying above the sea, or we are looking at a slow trajectory, like a trajectory of tail lantern, which is another hypothesis matching with what happened. Of course, at the end, we have a separation of objects, and it's not clear if it's a reflection or if it's a physical separation. So this case is very difficult, clearly, and we don't have a clear conclusion, especially because it looks like it's fading and disappearing behind clouds. And in this case, we found that perhaps this object could be a UAV, or possibly 2 UAVs flying closely and flying low. And in this case, you can imagine that when it's flying above the land part, this is not the sea, this is the land, you will have the effects of microclouds, absorbing the radiation from the object, so hiding it, then it reappears. On the sea, that's a different story. We think that it can, if, for example, it's a UAV with rotors, it could fly very low on the water and create, in fact, some kind of water dust, and this water dust could be cold and reduce the signature and make the object disappear. But we have to say that we don't have a clear and sure explanation about that. So to summarize, possibly tail lantern, possibly UAV or something else. Of course, the point not of disagreement, but I would say different understanding of the phenomena with SCU is that we couldn't consider the fact that the object was undersea, because if it were undersea, the infrared signature would be completely absorbed, would disappear because of the water effect. So, explanation complex. We rebuilt the possible trajectories thanks to the optical observation, the line of sight envelope. We couldn't use radar observation information because we had nebulity reflection on clouds, if you wish, by the radars, the traffic control radar, but the observation of the object was the yellow diagram that you have. It's not matching with the radar plots that we have collected apart. So that's a complex analysis, and this is why analyzing UAP observation when we don't have radar information is something very, very complex. We can make complex computation. That's what we did. We issued a report. This report is available on the website of EEF if you are interested, in French, but also in English, and we will be very pleased to answer any question. Now, to finish this presentation and answer questions, of course, we are interested in ground traces, okay? These are photos taken, I think, in the 73 or 75 in France by French gendarmerie. This is the case of Trans-en-Provence, very famous, which happened in 1980, and in this case, 81, excuse me. In this case, we had mechanical tracks in the ground, but also effects on vegetation. And we have experts working out comparison of effects of radiation on human being. We have a physicist, an expert in radiation, effect of radiation on human being, who provided a complete analysis of the effect on microwave on human being. And we saw very interesting similar things between UAP cases with close encounter together with effect of microwaves, but we also comparing the effect of microwaves on the vegetation in case of object tracks on the ground and on vegetation around. We have also started some analysis of samples. We are working with Jacques Vallée on that, and so materials, but also on the trees bark that has been exposed to a very strong radiation. That's something which is ongoing. So to finish with this presentation, I would like to say some words of one case which is completely crazy. That's the Lekanith case. This case is back to 56. There is no explanation. People observe light phenomena, okay, but also not only one light, but several of them with geometrical shape. These objects, in fact, fused together, okay, then stopped, then moved again. They observed and recorded this also with radars. Yes, with radars measuring speed up to 4,000 miles per hour, which is completely incredible. And this is something really which is very impressive, and there is no question about that. This type of UAP phenomena are very interesting, and we need more of them. We need measurements, not only optical observation, not only infrared recordings, but also radar data, because this is the only way to measure the kinematics, to measure the velocity, and try to cross-check things. So, in this case, they sent a fighter to intercept the object, and finally the object was in the trail of the fighter. Okay, that was not funny for the pilot, but fortunately everything terminated fine. So Nimitz case, in fact, it's a slide to make no comment. In fact, we have no comment about that because we don't have any information, any report available by the US Navy giving information not only on the optical observation, on the IR video, but also on the radar data. This is very unfortunate because if we had this data, we could conduct an analysis, but it's too much difficult. I think you understand because of our presentation, what is the complexity of an analysis. And if you don't have the range, if you don't know where is the platform of observation, if you don't know where is the object, it's really complicated to go to any conclusion. It doesn't mean that it's not a very powerful and important UAP case, of course it is, but we don't have the elements and the data to conduct our own analysis. In this case, and I finished, this is the case that happened in France in '94. I already described this change of shape, circular, then a dart, then disappeared. The important thing is that we have a radar track. And this radar track was not on the left. Here you have the velocity vector of the aircraft, okay, the heading. Here, this is the optical observation on the left side. But on the right side, you have the radar track. Radar track recorded by the French Air Force and provided to CNES, JEPA. And what is incredible is that this radar track is perfectly synchronous with the optical observation, except that it was not located at the same place. It was on the right side of the aircraft. And we don't have any physical explanation of that. That's interesting to study the radar records and the optical records in order to compare them and to analyze what happened, okay? Where is the center of phase of the radar reflection? Where is the location of the infrared radiation? So I mentioned Jersey case. This is under analysis. We have on this slide radar plots. We are analyzing different radar plots coming from different radars with this very strange oscillation, very connected to the observation from Ray Boyer, and we hope that in the near future, we will unveil our analysis on that case. Just to finish, observation using optical trajectography with different cameras, like the ones used to track meteorites, that's important, and also combining them with other sensors to conduct spectral analysis, possible radio frequency recordings, and of course, not only optical observation, but radar observation as well. So, conclusion, there are plenty of anomalous observables, kinematics, electromagnetic behaviors, interaction with the medium, ground tracks, and so on. Some of them could be related to microwave radiation. That's why the records from the RB47 are interesting. That's why the records from the ELINT device by B52, as they are recorded in Blue Book, in Malmstrom case, are very important because we could maybe relate this electromagnetic radiation with plasma effect, with optical signatures, and so on. Thank you for your attention.
All right, great. Thank you very much for that great presentation full of data and research. I really strongly feel and repeat that I think that Aero and the United States can learn a lot from the French investigators who, as you've mentioned, have been doing this serious work officially even for many decades now. All right, let's look at the questions here. The first one, could you discuss what you think are the best physical evidence, physical trace, and artifact type cases?
When you say the past trace, which trace are you thinking of?
I think they're wondering what what you think are the best physical trace evidence cases.
Well, concerning the cases, we have several of them. I mentioned, for example, Trans-en-Provence in France. This case was mentioned during the Quantico seminar that happened, I think it was in '98, I think so. And this is incredible. Why? And we have several of them in France because you have some mechanical effects. on the ground, okay, with some physical modification of the ground. You have also some traces of possible microwave effects on vegetation. And we have to analyze that. The question is, what produced that? Probably microwave radiation. And as I said, we worked not on the French cases, but there was a collection, an inventory of cases with interaction between UAP close encounter with human being, and our physicist, who is an expert of radiation effects on human being, conducted an analysis, very interesting. And by the way, he really identified the effect of the thermal effect of microwave, okay, under the skin, the effects on the heart, you know, and on memory, different levels. So we have identified that type of case in the past. And for example, there was a summary. It was through, we read that in Elements archives provided by CIA on events that happened. And in this case, it was in Ural. It was not in the US, it was not in France. It happens with Russian troops, okay? And the guys observed a light, okay, an object landing. And afterwards, they lost memory for a while, okay? This is type of effect that can happen with microwave. At the same time, we have experts on direct energy weapons in our team, in SIGMA2, and they explain very well the effect of electromagnetic radiation in the case of Tehran case, for example, creating a temporal neutralization of the electronics equipment. That's the same story with the cars, okay? That's very well known. In case of close encounter, sometimes, okay, the engine shut down, okay? That's another example. But back to airborne case, Tehran is one. The Airbus case in France was very strange, and we don't have explanation about that. Then, of course, some more recent case, we think that the Jersey case is a strange one. We think so because the observation by Rebauer, we are very lucky. We have the records, the audio records, we have radar records, we have this observation, so we are working very closely. These are interesting cases. And of course, what happened on US airbase, parts of the Blue Book records, but also in Russia, that's interesting to analyze. And some cases are mentioned. We have also the case that happened in November 1990 in France with a re-entry of rocket, but at the same time, different observations were made. And we found in the UK MOD files some reports from fighter pilots on Tornado, and they observed a strange aircraft positioned ahead of their Tornado, surrounded by a blue glow. And at the same time, we have also testimony from French military pilots. So that's something interesting to look at more closely.
Thank you. Another question is regarding radar. Are you able to obtain radar data from French civilian and military organizations?
The answer is yes, but when we say we, it's a collective answer. I mean that in France, there is an institution, okay, in charge of the investigation. Okay, this is GEPAN. So, for example, what happened with the Duboc case is that some information were known, of course, from the aircrew, okay, because they made the observation. They didn't make a report at this moment, but later on, they knew that there was, for example, radar track record by the French Air Force. This radar track was then transmitted, forwarded to the CNES GEPAN, okay? And then the CNES GEPAN conducted an investigation with the different contributors and had this own analysis. Conclusion, no conclusion, no explanation. And then we worked on that. I have to say that SIGMA2 has no further explanation, except that we really identified an anomaly, as I explained, between the location of the infrared, or not infrared, excuse me, optical observation, okay? The object was seen on the left sector of the aircraft, and the radar track was at the same flight level of the aircraft. It was perfectly synchronized with the observation. It disappeared exactly at the same second. And when the crew said, okay, we don't see anymore the object, and they are not located at the same place. And normally they should be at the same place, okay? So that's strange. And yes, in some case, the CNES Japan has an agreement with the French Air Force, with the CDAOA, okay, which is Command of the Air Operation and the Air Defense, equivalent of the NORAD, if you wish, okay? And they are providing, under request of CNES, radar records whenever they have, and if they can release them, okay, maybe they don't release all of them, but they are playing the game and they are providing, and in this case, they did their job, okay?
Great. Thank you very much for that answer. The next question, could you please expand on exactly what SIGMA2's role is in making case investigation recommendations?
Well, we are making a recommendation on several aspects. We are not conducting, if you will, investigation in the field, okay? When there is, in France, to start with, an observation, we are not making contact with the guy who has seen something. And when we receive mails, okay, we say, hey guys, please make contact with the French Gendarmerie or with the CNES Japan, and you will be listened, you can deliver your testimony, and they will investigate. When they have investigated, okay, that's a different story, because we have the material provided by the investigation, and then we can conduct analysis. And there are two ways to do that. One is being part of the College of Experts of Japan, with other, I won't give names, but there are guys who are famous, and we are really part of the Japan file, if you wish. And then afterwards, when Japan has released its analysis, because they are not conducting studies, we are conducting studies on our side, we are conducting analysis, and we can provide further analysis, if you wish. Just like what we are doing, we did with CEFA. We didn't conduct any investigation in Chile, of course, but we used the information they provided to us to try to find an explanation. And in this case, we found it, okay? Aquadia is different. It was not provided by the border surveillance forces from the US. It was from SCU, but we analyze the data and we provide our analysis. And we are making contact with universities, also making recommendation observation, because we have experts in infrared observation, okay, infrared signature measurements, ball lightning observation, all that stuff, and radar detection also. So we can provide analysis and also recommendation in order to improve the observation and the records of the UAP's case.
Great, thank you. And I'm going to ask one last question. We might go over a minute, but this is, I think, an interesting one. The European Space Agency seems to be unwilling to talk publicly about UAP, at least to the knowledge of the person asking the question. Seems to be accurate. How are you handling your relationship with the ESA?
We don't have a direct relationship with ESA at the moment. It could happen. First of all, we have a former ESA astronaut, Jean-François Clairvoy. He is part of SIGMA2 commission and part of AAAF. So we had many occasions to discuss with him about what happened in space, what they could observe, and so on. We have contacts with Philippe Ayris also, but we don't have a formal contact with the European Space Agency. I would say that certainly something could be done if there is any intent from ESA to obtain explanation, to go through the French CNES and Japan, possibly, to be supported or help, okay? Even if the CNES Japan has not especially a role outside the French borders, okay? But they are naturally a relationship with the European Space Agency. So this is something we have to discuss, just like Japan has contact with NASA, okay? During the CAIPAN seminar, we had a speech from the, I don't remember the name, but from the person who is in charge of the scientific research for NASA on UAP. And so he made a presentation, and for sure we can build up some links and be supported by CNES Japan. We work together, you know. We are not competing at all, and we don't have the same role. We have the chance to have very good experts, people working on different subjects, from plasma to directed energy weapons to microwave effects on human being, you know, radar detection. Different areas gathered in a team, and then we can provide this expertise to support Japan, to support maybe your Space Agency for some analysis of case, if it happens. I'm not aware of that for now.
Great. Thank you very much for answering those questions. We're now out of time. It's time for the break, but thank you very much for participating. I know that SCU, we're very excited about our relationship with you all, and thank you all for your efforts and your help.
Thank you to you. Thank you for your organization, because it's really perfect, and also for your confidence in our participation. It's a pleasure. Thanks.